Good evening, everybody. But unfortunately, I was called for this lecture today. The information was given on 13th morning. 13th, I was not in station. I came only yesterday night. Even the presentation I had made in a hurry, which is I think 2.5 hours we have done it. There might be some spelling mistakes. Because I am not a English lecturer or basically an engineer. Always we make mistakes in spellings. Kindly ignore the spelling mistakes. Regarding technology in food science, I'll tell you a small story before I start. This was in I think 2000, first gym was organized by S.M. Krishna government. We had a principal secretary for Industries and Commerce, Vishwanath. I had applied for a single window agency clearance for 27 crores. In that 12 crores was for making vermicelli. The open meeting, it was almost about 400 people were there. He was asking me in Kannada, "Yen Maiya avare, or shavge madlikke nimage 12 koti beka anta kelidru." In 2 minutes I could not speak. Then I told him, "This is not what we make in the house. The capacity of what I am buying is 1000 kgs of vermicelli per hour. And it is a complete continuous plant starting from actually collecting the semolina and ending up with packed vermicelli. There were 17 stations in that. He could not understand. Then I told him, once it is erected, please come and see the plant. And he came to the plant. And after seeing the plant, he said, I will never think of here afterwards. Whenever anybody says of any technology, I will not speak a word. Then he came to the spice plant. Then I said, it is also a continuous plant. And in Kannada he was telling me, "Yen Maiya Subbaman condiments ಗೆ machine ಬೇಕಾ ಅಂತ ಕೇಳಿದ್ರು. ಬನ್ನಿ ಸರ್ ಅದನ್ನು ತೋರಿಸ್ತೀನಿ ಅಂತ ಹೇಳಿದೆ. It is starting from roasting technology up to the packing technology. Almost about 17 to 18 stations were there. There also he was surprised. Now why I told this is actually in India as of now, except one in Pune and CFTR. CFTR is not exactly food technology, it's a food science. Just 2 minutes. Mic, light, everything, even the lights are working. Shall I continue? Before I think starting, I wanted to ask, is there any food manufacturers here? Any food manufacturers? Thank you. Not competition. I was actually, if anybody is there, I will speak much more than what I intend to tell. When I start actually food science is dependent throughout India, there are only 2 institutions. One is CFTR, another is in Pune, there is a food technology. What I am telling now, you cannot find in any books. Unfortunately, I think it is not taught as technology. Or in even IITs also I had verified, it is not there. I fought with actually Bangalore University and said, why can't you start food technology? So they are fighting in between the registrars and finally I think it has not happened. Then I went to Tumkur University. I think you can see from next year, they will start BSc Food Technology. Why I am telling this actually, I think when we start this kind of industries, why food industries are not coming in Karnataka and other places is actually we don't have institutions for teaching this kind of technologies, which is unfortunate is actually we take people from chemical engineering and others, and now actually if we can't believe, we are taking people from DFRL trainees because we don't have people who knows about food. In basically actually in processing, it's about 17 divisions are there, 17 to 18 divisions are there. I have taken only basic 5, wherein actually most of the items are coming in processing technology, and preservation technology, frying technology, freezing technology, and packing technology. In processing, actually, a lot of other technologies are coming. The processing means actually it is not only just processing, it is for continuous processing plus the batch processing and also certain items actually when we manufacture. What are the technologies involved in? Different technologies are involved. Next comes the preservation technology. I will come in detail. Preservation technology, I think from the beginning, it is not only in the industry, even in the villages also, we have this kind of preservation technology. Like actually, I think in our earlier days, we used to preserve actually pickle. Pickle, today they call it as actually low acid foods. Technologically, it is called low acid foods, but it is a pickle. If you keep actually the pH value less than 4.5 and the salt content is approximately about 12%, you can keep it for I think almost for more than 3 years, 2 to 3 years. Like that, actually, I think we have the latest technology in preservation is retort technology. I will come to it later. This actually preserves food. It's made food for 2 to 3 years, starting from 1 year, depending upon the layers of the lamination for the packaging we use. It is approximately from 1 year to 3 years. Then the frying technology. Everybody thinks it is a simple technology of just using a bandli and a kurpi. We say that it can fry anything, but it is not the technology. The latest technology is actually spraying oil at the top, wherein actually it consumes less oil, plus at the end of the tunnel, that is after frying unit, we use what is called as centrifugal force for removing the extra oil when it passes through the conveyor. This is the latest technology, I will come later. Then comes the freezing technology. In the freezing technology, about 20 years back when it started, they were using actually technology called blast freezing. Blast freezing is actually they construct one chamber first, cold room, they call it as cold room, either it is run by freon or ammonia. Then they come to the blasting means actually forcing the air to the product, whether it goes inside or not, but it takes more time. Then came actually the second actually which is called IQF. I'll come to this freezing technology later. The third one is actually the latest one, the spiral freezers. And the packaging technology. In packaging technology, we have actually different technologies. Basically, we use the auger filler, then the wave filler, then the cup filler. The latest one is a combination of all three. Now coming to processing technology. I will actually come to what I am making. See, there are about more than 23 technologies I am using in this. That's actually I choose on this. Processing of blended spices. Everybody thinks it is a very, very easy method. It is not easy. See, in spices actually, the basic problem is, basic spices like chili, turmeric, dhania and jeera contains pulverizin, what is called as the oil, non-volatile oil, which is not soluble in ether extract, which gives a flavor. Basically for chili, it is about 12 to 16%. Here also what is happening is actually in the beginning of the season starts from March, April. And for the first 4 months, it will be between 16 and 17, and it reduces to almost about 11% in November, December. Our intention is actually to, when you grind or roast or fry, the basic problem what we face is, suppose we get actually the material in somewhere in December, January, February, March, wherein actually in places like Hubli and Dharwad or in Guntur, we can get rain during that season. And if the moisture level goes beyond 13%, then what we think is actually by just roasting, we can remove the extra moisture. But technologically actually, we have tried. This actually applies to coffee also. When you roast at the temperature of almost 3, at the moisture level of almost about 13 to 14%, what will happen is, along with the extra moisture, because usually when we roast, it has to be between 10 and 11%. If it is 10 and more than 10 and 11%, automatically what will happen? We use extra, what is called as heat, to remove that extra moisture. And the time taken is little more. With that actually what is happening is, basically our intention is to maintain that aroma, hotness and color. Along with the vapor, I think even the extra flavor also goes. This you can see straight away in coffee. Coffee actually when you roast the fresh seeds actually when it comes to the market, it is approximately about 75 kgs per bag. And having a moisture of approximately about 13% moisture. But coffee is just like rice. Older is better. Theoretically, what the reason is actually the same reason, what I told. At 13% if you roast it, along with actually the moisture, your oleoresin also, caffeine also evaporates. So you won't get. Typically actually, when you roast this kind of coffee seeds, when the moisture is 13%, that is freshly graded, you can see actually the smell of, suppose in South Canada when the rain is coming, when you spread your wet cloth, you will get particular smell. That smell you will get in this coffee, particular coffee which is where the moisture is more. So what we do is actually, we first reduce this kind of extra moisture by a natural way. Artificial way you should not use until it comes to about 10%. Example is actually once in coffee in Maiyas, earlier in MTR, now not in MTR, now it is in Maiyas. We actually keep the stock of coffee, that is last year's coffee we are using this year. Almost about 1 year coffee seeds we roast, we keep. The keeping method is actually, storage method is actually just like actually using a plank. You might have seen actually the planks are seasoned by using some particular way, wherein actually air can go inside and it can remove the extra moisture. The same way we keep the coffee seeds also. The coffee seeds actually when we buy it is approximately about 75 kgs, and when we start using it, that is after 1 year, it will be about 72 kgs. Approximately about 3 kgs loss, 3 kgs about 4 to 5%. That means exactly from 13 or 14%, it will come to 10%. Then we roast it. Then we grind it. Just like coffee, even the spices also. Unfortunately, what is happening is actually I think spices roasting is different process. I will come to the roasting process a little later. And first actually, when the process is actually cleaning up for heavy particles, heavy printing, it is called destoning. Cleaning for light particles. So now I actually think if you are exporting to USA and especially China, Japan, they are asking actually what is called as actually the percentage of dust. Dust means actually the extra portion of dust. They are not allowing more than 0.002%. So for this actually what we are doing is, we have developed a machine. It's made in Pune, but the technology is from Germany. Then actually we have drying, roasting and moisture control and aroma, that I will come to later. Then hygienic storage. For blended spices, mixing of spices as per recipe, grinding of mix using pounding, blending of finishing ingredients. These are the Indian spices, different spices. Now I will come to this technology for cleaning and destoning spices, technology for drying and roasting, using actually infrared energy, technology for hygiene storage, technology for accurate weighing and blending, technology for continuous and superior grinding, technology for final packing and bulk and small packs, technology for computerized plant and process control. The left side actually what you are seeing is they call it as a destoner. Along with the destoner, we are using a special technique giving extra air, and the dust also evaporates from the other two. As you can see, I think sides you can see. There actually to go to the dust collector and we collect it and burn it. The second machine is actually the heavy stones. The third is the mixing. Last one, right hand side, is actually the storing. But most of this actually what we do is we never allow these things to keep it in open. The contamination, aerial contamination will happen if it flows, whether it is by manhandling or other things. So what we use actually the technology called using actually positive pressure. Pneumatic systems we use for transferring from one to other. This is actually the equipment for drying of spices and roasting of spices. You might ask me, I think, why we waste this kind of money for, it's a very costly machine, almost about 1.2 crores. The continuous plant actually from one end to other end is actually 1.5 crores, 1.2 crores. It starts from actually at the end is actually the preheating system. All these actually the spices, whether it is chili or dhania or jeera, especially this chili, it requires actually some spraying of oil. And even in the house also we do the same thing. Only when you roast chili for making sambar and rasam, making the masala, we roast it in oil. The reason is actually very, very simple. If you roast dry roasting if you do, extra olive resin also escapes and it becomes black. I think everybody knows this theory. So we use actually extra spraying of oil when these kind of materials are coming. First is the preheating. Second is actually the infrared. You may ask actually why we are using infrared heating. Technology is here is actually usually in the house or in small factories. We use actually the gas burners, electrical burners, and sometimes actually we may use actually the steam generated kettles also. But in those cases actually the yeast mold, I think mold and the spores we cannot kill. Even at the sea, we are not going beyond 80 degrees. Maximum we can go up to 65 to 80 degrees for roasting extra, removing that extra moisture from say from 13 to, we may come to 6 or 7. But unfortunately actually what will happen, these kinds of, what is actually exactly which is coming from the field, we cannot clean those materials with water. For example, chili, we cannot wash it out. So the best method is actually to remove extra portions by using this kind of method. Infrared actually kills those bacteria and the molds and the spores. So we use infrared. One is actually to reduce the cost. Second is actually this is the best method where you won't get charring. Charring in the sense actually you use any roasting methods, whether it is a cylindrical roasting or a cement roasting, mixing kind of things, anything you use. At the end actually, where actually the chili or the other items. See in here actually the biggest problem in spices is, it's an agro-based product. You won't get actually the uniform varieties. See, for example, actually if you use methi, you get different grades. When you sieve it actually, almost about 6 to 7 grades you are getting. In roasting, the biggest problem is actually when you roast actually with this regular heating, with either it is electrical or gas heating, the biggest problem we are facing is the smaller size becomes over roasted and becomes actually, in fact it becomes, because if it is methi, especially in methi, if it is over roasted, you will get actually the bitter taste. So we want actually the exact, each material should be 100% cooked and it should not be overcooked. This method, infrared method, will never actually allow this to overcook. You won't get a single charring particle by using this method. And then actually afterwards it is a fluidized fuel. It has to be set, the temperature is about 70 degrees. For grinding actually we require the temperature at almost about room temperature. It is about 25 to 26 degrees. In Bangalore and other places it is about 30 degrees. To achieve this actually what we do is actually all the materials, because actually bulk density of each material is different. It varies from 0.4 to 0.8. With this actually any method if you use for cooling, you won't get the uniform cooling. We use actually the fluidized bed, wherein actually it floats above the belt. And we actually give cold air from all sides. 4 sides we give. So automatically whatever is inside is 100% cooled. And it takes, the total time taken is approximately for the cooling is about 10 minutes. So from 75 to 76 degrees of 76 degrees to 25 degrees, it will come in just about 15 minutes. And when it comes, next is the storage. This is very important actually. I think if you have HACCP and BRC and ISO 22000, this is one of the conditions they say, we cannot store these materials in open space. Unfortunately, items like chili, when you roast it, extra moisture goes. But if you pack it in a tub or pack it in any material, plastic material, there is what is called as sweating will happen. Approximately you can say 2 to 3% of extra moisture will sweat and it will deposit in the chili and other places. When it happens like this, again the moisture will go up and you will have the other problems. So the best method is actually in earlier days we used to use the gunny bags wherein it can breathe. We use actually, I think right hand side you can see these are the material, these storages wherein actually we have what is called as maintaining the 25 degrees or 26 degrees, a cooling chamber outside. You can see it is little thicker than, the right side is thicker than the left side. The basic thing is actually, it is actually what is called water cooled. The temperature we maintain is about 10 degrees, plus 10 degrees, so that actually the temperature from 75 it will come to about 10 degrees, sorry, 25 degrees, and it takes approximately about, you can say, 15 to 20 minutes. Once we keep it here, and even if you use it next day, nothing will happen. Large capacity different blenders. See, usually for mixing of these spices, it is not so easy because actually both the bulk densities are different, plus actually the sizes are different, chili is different, jeera is different size, methi is different size. When you mix actually, the proportions actually what we mix should be uniform actually when you grind it. Otherwise actually in the beginning you will get actually the powders like methi, jeera and dhania. And finally at the end actually you will get which is less dense. Is chili powder you will get at the end. Then you have to mix it again. What we do is actually use a special purpose. It is called IBC. You can just see. It's a prototype. I think it's ready now. It's next and it's closed. Then it rotates. The entire thing rotates. Why we selected this method is, if you mix anything inside, you will not get the uniform thing. Here actually, the picture I think you might have seen, the entire bowl rotates. When the entire bowl rotates, even the mixing of actually the ununiform materials will be the uniform one. Once you do like this, we will be doing for almost about 10 to 12 minutes for getting a batch ready for grinding. And the next stage is grinding. In grinding, I think these are the methods we use, different methods, but I will take only the dry milling. Usually in grinding spices, in the most of the houses you might have seen earlier, any grandmother is here. I think they used to have the original pounding. In the pounding actually that is the best method even today. The reason is actually, generally I think in the initial stages we used to grind it by what is called as ragi mill, the flour mill. The flour mill actually one side you will have that iron one and another side it is a stone one. in between when you put materials, because of the aberrations, the main spices will be grinded. But the unfortunate thing is, in this kind of grinding, all these materials contains the olive resin. I think I told in the beginning itself. In chili, actually, it is approximately about 12 to 15% average. And because of this olive resin, when it is grinded like this, first 5 minutes you will get the best one. That is a chili powder color. The next 15 minutes you will get a little brownish, where actually charring of this olive resin happens. Then after that you will get the burnt black powder. When you mix and give, you will get an orange powder. I think most of you experienced this. The next actually the technology which came in 70s, 75, 76 is what is called a hammer mill. In hammer mill actually the technology what we have done is actually hammers are hammering in a closed chamber. When it rotates actually at the end of the channel, I think we have put actually the mesh. When it comes to the mesh, automatically you will get a powder in a particular size. But here also, the temperature will go to almost about 60 degrees within 10 minutes. In grinding actually, first 5 minutes it will be at 35-40, and the next 10 minutes it will be 60-70, and within 15-20 minutes it will be approximately about 80 degrees. Because of that actually you get the burnt this thing. In hammer mill, it will go from say 45 degrees to almost about 70 degrees. But it is little better than the grinding. Next came actually the pin mill. In the pin mill, it is not in dry milling it is there. In the pin mill, the reverse of hammer mill. Instead of hammers are rotating, the cylindrical this thing is rotating. Then came actually cryogenic grinding. In cryogenic grinding, actually when these regular hammer mills are there, it is actually filled with liquid nitrogen. The liquid nitrogen are given, the temperature of the product comes to almost about, you can say 2 degrees, 3 degrees. So there is no scope of actually increasing the temperature when it is grinding. But unfortunately what will happen, in cryogenic grinding, there is an increase of approximately, you can say 5 to 10 degrees, immediately the product is put. And continuously it will maintain that. Instead of actually room temperature is 30 degrees, it will maintain at 35-36 degrees. Because of this actually there is a flavor loss and the color loss of approximately, you can say about 6%. The last came actually the pounding, which is the best even today. But in pounding, I'm not showing the pictures because I don't have the time now. In the last actually I think the pounding, it's a traditional pounding but we mechanized it. It's a semi-automatic. There actually one problem is there. Pounding also, it takes actually a lot of time. Time in the sense the production is approximately, you can say 18 kgs per pound, per hammer. And you cannot make in tons. And the next problem is actually in pounding, even in pounding also, is the worst is actually the particles, smaller particles, with you can say between 500 and 300 microns. It flows on actually the surface area where actually we breathe, we'll have a problem with the nose and other things. Plus actually for me, as a manufacturer, we are losing approximately about 4% by wastage by using this method because of the particles which is not coming back to the material. What we do is actually, technically, it is our own invention. This, the first one, what you call as turbo mill, or I call it as stud mills. Stud mill means actually it is nothing but actually a kind of movement of the particle through an artificial, what do you call as routing. It will move like this. Here actually what is happening is all the materials, well, as I told you, is between 0.4 and 0.7 bulk density. Because of that actually, one side we push the material through this kind of waves, another side actually we pneumatically you suck it. Automatically it will not heat at all, but you will not get actually the fine powder. It is what is called as actually preliminary portion for grinding. That is actually before grinding we use this method. Or I call it as disintegration. Majorly actually see from the coarse material, it will come to almost what you can say 150 micron. With that actually I think we have to go to 500 micron. The next method actually is Earlier we used to have this, what is called as pounding. Now actually I think we have come to, this is actually the stud mill structure. The black one is actually the studs. Like that I think approximately about 270 studs in the area we have created. These both male and female side, different sizes are there. And the roots actually, the plan actually what we do is in a different way, so that actually when it moves in a circular way. When you put the material at the top, when it comes down, it is a crushed one. Doesn't generate any heat. This is a new invention we have done. It is called actually vibrating mill or rod mill. It's the same technology. In hammer method, in pounding, the biggest problem is when you pound it, manually it is semi-automatic. Manually you have to push the material. Otherwise actually only at the center it will pound. The balance portion to push it, you have to push by manually. Here actually what we have done is a reverse of pounding. Pounding actually we do like this, with big hammers with 6 inches rods. Here actually what we have done is, instead of the surface, to increase the surface area, instead of straight putting like this, we have hammers actually like this. The same thing like hammers, so almost about you can say 24 inches. Hammers will be there. That will vibrate in uneven. I think I will show you later. In this actually what will happen, the surface area of hitting area is more than, say there actually it is 6 inches, it is 6 centimeters. Here it is almost about 220 centimeters. And it vibrates in different methods. That is actually using cams and other things, and vibrating systems are different. Because of this actually, inside, I will show you that. This is actually what is called as the rod mill, what we have developed. Technology is by Maiyas. Maiyas means Sadananda Maiya. This actually we have developed in Pune. One of my classmates was an technologist. He went to afterwards from BMS. He went to Germany, and from Germany, when he came, he started this kind of innovative product. This actually idea was given by me. I was thinking actually from the beginning how to increase actually the capacity, because what we wanted is approximately about 2 tons per hour capacity, which is not possible by hammer mills at all. So what we have done is actually this outer surface, you can see, is a jacketed one. It is a air-cooled one. And this side is actually a eccentric motor, which actually vibrates in different directions. You can see actually the inside, the green and the red and the blue. These are rods. Are actually the rods. They are approximately about 26 to 7 inches rods, which vibrates through this motor. Earlier motor I had seen. And when it vibrates actually, the entire thing eccentrically moves. To control actually what is called as the vibration, we have put these springs. So that actually the sound and even actually the what is called as the vibration is controlled. Here actually when it vibrates in a different directions, automatically you will get actually a feeling like hammering in ununiform method. Because of that actually, other side, you put the material here, you get actually the material on the bottom like this. It's like this. This is circular movement, elliptical. Then actually this is the grinding zone where actually the material moves like this. Then this is the linear swinging. Linear swinging in the sense actually what we do is swinging actually at one center if you put, it will move like this. If you end actually put, it will move like this. We wanted actually a movement like this. It should hit everywhere. For that actually we use this method. Next comes actually the packaging. This is actually rod mill. This is the first time in India we have used this method, not this, the rod mill method. And the flavor, what we have attained, which is approximately about 15 to 20% extra compared to my own method of pounding. This is because of the aroma loss plus actually the flavor loss which is happening in this. Next came actually the packing methods. You might have seen actually in most of the materials. Example actually this, even including the raw materials. The jeera, then coriander, jeera means cumin seeds and the coriander, and most of these except chilies, you keep it in cold storage. You keep approximately about, you can say, 6 to 8 degrees plus. The reason behind it, actually, I think you might have seen in the house also, every 3 months, once in 2 months or 3 months, if you buy in the beginning of the year, which is approximately about April, May, you will get actually dust formation plus actually the fungus formation. To avoid that, everybody keeps this in cold storage. In cold storage, one big problem is there, where it attracts more moisture. When it comes to the, again back to the bags, it attracts approximately about 2 to 3% extra moisture. To avoid this, we have started using the other method of packing these raw materials in vacuum conditions. That is one. Second is using carbon dioxide. Carbon dioxide is opposite of nitrogen. Nitrogen actually, it expands. But carbon dioxide usually when it is used, it will be contracting. You can see once a carbon dioxide, once you make vacuum and use carbon dioxide, the shelf life of the product is 2 years. Even regular jeera and coriander, you can keep up to almost about 2 years. This is actually what I have shown is on the left hand side is the bulk packing, vacuum packing. It's the machine for that. This is automatic robotic packaging machine, what we are using. This is actually the latest packing machine. Wherein actually we provide a film here, then it is, the gazette formation is done, then actually next it cuts, then the base, then it packs, then the sealing happens, finally it comes to the end and then it fixed by pneumatic systems. Here it is cutting. Here it is cutting. Cutting. Here we put here, it's an auger filler. You can put any fillers. After packing, filling it. Third thing is what is barcoding is done here. Manufacturing, experiment, all this. Fixed up here numerically, it puts on the conveyor. Then it goes to tech weighers to verify the weighment. It is even if it is 1 gram less or 1 gram more, it rejects. Tech weight. Then it goes to the cartonator, then it goes to the outer cartonator, then tracks and goes. And the entire system requires only 2 people for control. And we pack approximately per hour approximately, can I guess? It's 3,600 coaches per hour. That's the capacity. 60 to 80 we can go, but certain materials actually, for example, like this gulab jamun and other things we pack only 60, and lighter materials we pack up to 120 packets per minute. This is actually the overall view entire spice plant, when I was an MTR, the number of people required for making about 10 tons per day was about 170 people. Here, about 250 tons per day, you can keep only 17 people. This is technology. Next, the preservation technology. Like this, actually, I think we have different methods of packing. We have actually the regular packing machines like this, plus the wave fillers, using different heads. And the cup filler. Cup filler is actually for uneven surface, like actually we are packing kara only and other things. This is all uneven. Like puliogra also is uneven. We are like putting extra groundnuts and other things. So automatically it requires, actually it can't come through the auger filler. Auger filler is actually for packing the straight items like gulab jamun mix or rava idli mix, all these things you can pack. But items like puliogra, all these things we have to pack in a cup filler. Like this, actually I think totally about 6 varieties of packings available in the market in the world today. Next, come to preservation technology. As I told you earlier, even in the previous, lecture also I told about this. Traditionally, I think in the house actually, you can see in my native place, tamarind is stored without using any preservative, just salt. That means actually the salt proportion is approximately about, you can say 12 to 13%, and acidity is approximately is less than 4.5, the pH is less than 4.5. You can keep any material minimum of 2 to 3 years. I can guarantee you for 2 to 3 years. Now we are developing actually such kind of items without using preservatives. Next, processing technology in this, different types of containers, processing, food sterilization and in flexible containers. I will come to this later. This is the retort technology. This is the latest technology. Usually method of preparation is actually dehydration, fermentation, concentration and evaporation, freezing and refrigeration, thermal processing and canning or canning, eradication, high pressure, microwave, etc. etc. There are almost more than 30 preservation methods are there. Out of that, I think I will touch only the thermal processing and the freezing afterwards I come. Usually dehydration means actually when you reduce the moisture from say 13 to 14% to 6 to 7%, automatically the shelf life of the product goes to almost about 1 year. Any product. But it is difficult to reduce that up to that 6 to 7%. Next is the fermentation method. This is actually the same pickle varieties. They call it as pickled vegetables and other things. So many things comes under this. Concentration and evaporation. Here actually this is making, when you make actually the, for tomato actually what we do is we remove the extra moisture. See usually it will be approximately, you can say about 30 to 40% extra moisture will be there. When you remove that moisture, it becomes a concentrate. So tomato puree, when you want actually with the 26 to 36 bricks in the sense actually the percentage of solids, when it becomes 26 to 36, to make that actually we require this concentration and evaporation method. Then the freezing and refrigeration. Freezing means actually earlier there was what is called as blast freezing was there. Then came actually the IPF, then the last is spiral. Now what is running now, the new technology is spiral. I will come to that later. Then the thermal processing or canning. Earlier in earlier days also, we used to have cans. A lot of beers and other things I think used to come in cans. These are one of the uses of earlier technology wherein actually they never sterilize the product. It is only the temperature they go to up to 100 degrees for liquids only. What we have done is actually, we have done actually even for dry items. That actually process is called retort. In retort actually, before that actually I think I will explain, there are two technologies in this, processing technologies. First actually, filling, closing, sterilizing, and this actually in the contains of thermal processing, wherein actually in certain methods, like what we do in pouches, like you might have seen our ready to eat and other things. In ready to eat actually what we do is we make the material, then fill it, then we go for sterilization. After sterilization, the product shelf life is 1 year. The second method is actually we sterilize the product first, like Tetra Pak. We sterilize the product first, then actually we pack it in aseptic conditions. It will become, again the shelf life is 2 years, but only thing is the material what we are using should be of the 6-layer method what the Tetra Pak is giving. Function of packaging, usually for protect food during processing, transport and storage. Prevent post-processing damages, contamination, hermetically sealed containers. See, this actually, different countries will have different standards. In India there is no standard at all because it's a new product. Though it is from last 12 years it is there. Even now actually there is no standard for these things. In Canada actually they have a different process. They actually mention not only the temperature, this actually I will go to that next term. The record process is actually what is called as a F0 value. We have to achieve that F0 value for particular products. They are fixed. For example, liquid products, it should be at 6. Items like actually where the paneer are used, it is about 12 to 13. And similar products with gravies and other things, it will be between 8 to 10. Like that they have fixed. Plus actually they have fixed actually the pressure. At what pressure we have to seal this material, that also they have mentioned. And the sealing strength also, they said actually bursting strength and sealing strength is approximately about 12, which only Indian machines are not giving. We are actually buying an imported machine which can give 14 now. These are the conditions in different, say for Japan, it's a different condition. What they say is actually, contamination usually happens in sealing. Sealing actually the edges, it should not contain a material, single material. They have a machine for checking that. In the sealing actually, when the material falls actually, any material sticks to that seal, they say it is a contamination area which can develop after 6 months or 8 months. They don't allow this kind of material. So we use a different packing machine where the nozzle goes inside and doesn't actually make any this thing, and we sterilize the entire area before sealing. These are the new methods we use. In here actually, the second method of sterilization is metal containers. You might have seen a lot of juices, then staple food. Earlier actually soups are coming in this kind of metals, the cans. But the only problem in cans what we face is inside what is called corrosion, because it's made from tin. Now the new lacquer has come. We have tried in badam milk about 6-7 years back. We didn't have a problem, but actually the product is very, very costly because of the packing material. It's about, you can say material cost is about 4 rupees and the packing material cost is 11 rupees. And you have to sell at 25 rupees because actually excise duty, there are so many other things are there. So slowly actually this in India, not only in India, in the world actually the cost of things are going up. Because of that actually I think slowly the dependence on cans are going now. I think flexible packaging is coming. These are the regular easy open ends. Earlier actually we used to have that tin opener. Now that is gone now. Easy open ends are there. Then easy to peel materials have come. These are the advantages of metal. Strength unbreakable, suitable for vacuum and pressure packs, can be sealed at high speeds, suitable for retorting at high pressures. Total barrier to oxygen and moisture giving shelf life up 2 years. In any flexible packaging, it is not 2 years, it is 1 year. And here actually we can give up to 3 years also. But liquids actually we can give 3 years. Well suited to high temperature up to 135 degrees. And in flexible packaging we are going up to 127, not beyond that. Double steam tolerates significant pressure differentials. That is actually compared with the glass and flexibles. Suitable for retorting in batch and continuous systems with or without pressure. Easy to recycle. Disadvantages, what I told you is the same. Lacquer, if it is there is some problem, we will have a problem in contamination. Glass containers. These are actually the earlier 90s. To pack actually major applications, sauces, jams, baby foods, dressing and mayonnaise, fruit juice, beer, carbonated beverages. Now slowly it is moving out because glass is also becoming costly. Now exotic containers. You can see pouches, plastics, sauce. This is actually not in India. Then cartons. Cartons I think it has come, I think. Tetra Pak. And 1977 actually retortable or sterilizable pouches was approved for use for low acid foods by US FDA. Here actually, this technology came from Japan. Japan used this technology, retort technology. It is a crude technology at that time. And the technology what they have used is actually just a hot air, sterilizing in an autoclave in hot air, and the temperature they've gone up to 120. That's all, not beyond that. They used it next to the Second World War. All their saucers used to come in these packages, and actually at that time these kind of actually 4-layer, 5-layer pouches were not there. At that time they had only 2-layer pouches. One is actually polyester outside, and inside they have the polythene. These are the special varieties actually which is available in the market. These are plastic ones. These are actually pasteurized food, what you get in flight. Though it is chilled, it is pasteurized. Then it is the retort technology. Retort technology, I think up to 2007, people thought that it is not safe. People use, actually we use preservatives, but it is unfortunate to know actually we are not using any preservatives. It is actually, suppose if I give you your sambar from your house, I can retort and give it to you back. No preservatives are added. It is only actually the maintaining the temperature at 121 for 20 minutes. That's the theory. Retortable items, that is actually any liquid or any solids, gets actually sterilization using this method. But only problem is actually in this, the flexible pouches actually when it goes to 121 degrees, that you have to use the pressure. Pressure actually approximately we are using 4 bar pressure at that time. The pouches also expands. But if we allow it to expand, automatically what will happen? It may burst, or it may, see the air may, if the hot air may not go inside. What we have done with the latest technology is now, it is not only hot air, it is a hot steam spray. That's the technology we are using now. It is actually the latest technology as per FDA, American FDA. Unless you have this machine, they don't allow the packets to come inside America. This is actually, advantage is actually 100% it is safe. Safe in sense, earlier in all our retorts, where we use actually just hot air, the shelf life of the product, say when we make about 1,000 packets, we used to lose about 60 to 70 packets, either by damages or by not processing perfectly. We used to keep the packet for 10 days as a curing. Curing in the sense actually, suppose if any damages happens, it will happen in 10 days. Now with this new technology, with the hot air spraying, you can get actually 100% safety. All that 1,000 packets what we make, each batch is about 1,000 packets. 100% it will be, shelf life will be 1 year. Here actually, it is just nothing but actually sterilization. Here actually we heat the product first. And what is called as actually the heat versus the temperature curve. They call it as actually F0 value curve. Here is, this is actually the retort machine made by a famous company called FMC. You might have seen actually they are in so many other things also. In food actually, they are the best manufacturers of retort throughout the world. This is actually this tunnel you can see. Here actually we keep the packets on specified, actually they call it a specified channel. In that channel actually you have to push the material, it comes outside. Here actually they have put actually you can see squares. These squares are actually now for not expanding beyond certain time, so that otherwise actually the pouch may expand and may burst also. Then we increase the temperature. Here actually for each item we have different temperatures and different timings. F0 value, this is actually the curve actually what we get from the temperature versus delta T versus time. What we do is actually, theoretically, I think you may not understand this, theoretically, to increase the temperature from 0 to 121, initially it goes up to, you can say, 90 degrees very fast. From 90 to 105, we take about 5 minutes or 10 minutes. So from 105 to reach 121, we require another 10 minutes. And the theory says 121, you have to maintain minimum time of almost about 20 minutes. It depends upon the product again. See, for liquids actually it is 121 degrees centigrade and with 20 minutes. And items like difficult item is our cottage cheese. In cottage cheese actually this microbes count actually, whatever they say, it will be initial load will be very high. To kill that actually we have to go to almost about 121 degrees or 128 degrees and keep for 35 minutes. Then the F0 value will be 12. For regular products actually for milk and other things, milk, water, juices and drink, it will be about 6. Then regular products actually is about 8 to 10. And I got, I think, Mr. Dr. Ramrao had told the V. Subramaniam Award. That is for actually, until 2004, they had only the semi-solids in this sterilization. Even Japan also in the beginning stage, they used to sterilize only the semi-solids. I was the first Indian to make actually a dry product retort technology. That is for just keep the sterilizing rice. For that actually they had given that award. This is again by trial and error. I took almost about 3.5 months. This is actually to make, this is mainly for developing items for defense. For defense actually I had developed Defense Technology Absorption Award, I think you might have seen. That award is for, this is actually before the Kargil war. About 20 days earlier to Kargil war, Defense Minister requested me to make a bag. They had a bag actually for the forward areas, those who are going, they used to carry one bag for 27 kgs. They requested me to reduce that at least to 20 kgs. In that bag actually, they have morning breakfast, then morning tea, then 10 o'clock brunch, then 1 o'clock lunch, then 4 o'clock tea and coffee and the snacks, then again dinner, plus we used to give the burning burners, plus all these put together at least was 27 kgs. We reduced it to 11 kgs. The bag was actually just a handbag kind of thing. This actually with the Kargil war they used this. And after the Kargil war, I think 2002, 2001, they had given the award for making this. Usually that award goes to people like who develops this rocket and everything. First time in history, they had given it a food manufacturer for finding this kind of machineries. Here actually one of the thing I think, the initial temperature actually when you make the product actually it is about 70 degrees. From 70 degrees, we go up to 120 degrees. You may ask actually what will happen to the inside ingredients wherein actually we put so many other things. It is not only the flavor, nutrition value. At 121 with pressure 4 degrees there will be a loss of about approximately 10 to 12%. It is bound to happen. Now for that actually in another 10 to 15 years you can see this technology will go and the spiral freezer technology will come wherein actually the retention is 95%. This is the material what we are using. Earlier I think in MTR I used to have this aluminum pouches for retort. Material construction is actually in outside it is polyester for printing, then aluminum, then we have nylon, then inside it is cast polypropylene. Now the latest technology is, it is not cast polypropylene, they use actually polypropylene, which is a material which can seal the material, plus it can retail. In cast polypropylene, retortable cast polypropylene we used to have a problem because it is only imported and the shelf life is only just 12 hours. When it comes actually you have to keep it in freeze, but we had a lot of problem actually when you import it. In the customs actually they don't use these chilled methods. 4 degrees they don't maintain, automatically usually it is spoil, 50% is damaged. So we use this method now, this is the latest one, and now actually the latest one is actually in aluminum. We face the problem, manufacturers, and they make the aluminum sheet. As per standard actually, TFS standard plus the FDA standard, you must have actually number of pinholes. They have fixed a number of pinholes. It has to be 15 per square centimeter. If it is more than that, you will have problem with the permeability. So What we have done now is actually we have converted that to from aluminum this to now the silicon dioxide. This is the latest one, a transparent one which is microbial. The only problem is actually the shelf life. There it is about 18 months, here it is about 12 months. In the Indian conditions, nobody uses the product after 2 months. Though with the shelf life we say 18 months or 12 months, nobody uses after 2 months. Advantage is actually it's a flexible one, handling is very easy, lightweight, and compared to tins, this is much better. Disadvantage is barrier properties. In tins actually you can catch, our average is about 2 to 3 years, here it is just 12 to 18 months. Needs gentle handling, not suitable for high speed filling. Here the filling capacity, what I told you, I think it is filling, if it spills, it is damage. So we can pack up to 80 packets per minute, but in cans actually we had gone to 600 cans per minute. 600 cans per minute. Badam drink, what I used to sell, capacity is 600 cans per minute. But here actually we cannot go up to that level. And critical factor is seal, handling and heat treatment. It's already explained. And last is actually frying technology. Though we may say that it is a simple technology, it is not simple. Already 7:30. If you want to stop, I will stop here itself. In adapting heat wave technology to produce traditional snacks in continuous process, adapting vacuum frying to produce novel nutritional snacks, automation in producing ethnic South Indian snacks. These are all actually my experience I am putting. This is not the only one. I think I had seen actually a lot of other new technologies, but it cannot be used for Indian snacks. What is a heat wave? Heat wave is the newest patented technology available for frying. Heat wave has the lowest system of oil for any frying system, producing the highest product quality. That means usually everybody thinks that I think in a fryer actually you have to keep approximately about 2/3 the quantity of oil. Suppose the fryer capacity is 400 liters, means you have to keep about 300 liters at least. For if it is not running, you will have a problem. Second, in most of the items, when you put actually, say it is a continuous machine. Say for example, I will explain on Indian snacks. Say for example, we are putting kodbalai. And the kodbalai is actually, once you put at a time, we make approximately about 150 kgs per hour is the kodbalai capacity, per hour. 150 kgs. And when it falls on a fryer, what will happen is actually that fryer oil temperature also comes down. To keep actually the uniform temperature, we use this technology, heat wave technology. That means actually, this is the process. Here actually this is the oil tank, where we actually, when you store the oil, when you increase the temperature, this is actually the storage. From the storage it goes there, and through heat exchangers, it is heated here, then from there actually it will spray the oil. And here actually this is the minimum capacity of oil. Here spraying oil is actually the filling of oil. Here actually the best thing is, suppose any material consumes approximately about 30% or 45%. Kara bundi absorbs about 48% of oil. And other items is approximately between 30 and 45. Most of the items are between the range of 35 and 40. And that much oil, once it actually absorbs that much, it is actually a cleaning system. Here you can see, this is a cleaning system. All this dust actually, I think, whatever the wastes are there, which will fall, which will spoil the oil otherwise, will come to this, it will be separated and purified oil will go back again. And the filling of that oil, that means actually, suppose in an hour, when we produce about 150 kgs, it is about 45 kgs of oil is lost. That will be sprayed at the top, which is very hot. Very hot in the sense actually we are keeping a temperature of 175 degrees for frying most of the Indian snacks. Here actually, the best thing is actually when you spray oil, the temperature actually at the top, usually otherwise actually when the top actually, when you put vada, only half is actually sunk. The balance half is at the top. It is usually we turn it out. Here for a continuous fryer we can't turn it down. For that actually use this method, wherein actually from the top also it fries. It's a newest machine what we have bought. is the cleanest oil. In oil actually, when you fry, at least for I think if you fry the oil continuously, the oil shelf life is only 4 days. When acidity becomes approximately about you can say 3 to 3.4, we have to remove the oil. In any Indian fryer, continuous fryer, it will come if you continuously fry for about 8 hours per day, it will come in just 3 days. Here it will come for 18 days. 18 days you are not supposed to change the oil. And oil shelf life plus the product what we are making is 100% pure, plus all the systems we have introduced, wherein actually fresh oil, clean, filtered oil only will come there, plus that what is called as actually the temperature loss is taken care. All these are advantages of this fryer. Next comes the next technology, which is the latest technology, what is called as a vacuum frying. Has anybody heard of this technology? Vacuum frying. It's a new technology wherein it's a batch process, it is not a continuous process. We fry actually materials like the fruit, basically fruits, vegetables, and certain items, so like the kabuli chana, is very hard. When you fry it inside, actually the crust actually will not be 100% fried. That's why actually you will get it when you munch it, you will have a hard sound. But actually good cooked kabuli chana, when you crush it, you won't get the sound. That is the test we do. Here actually vacuum frying means we are not going up to 170 or 180 or 100, even 165 also. The temperature what we are keeping is 130 compared to 170 using vacuum. It is first actually vacuum is generated, then the extra oil is removed, and the consumption of oil is up approximately 30% less than what you fry in regular machines. This is basically used for example, you might have seen actually Vietnamese product, the jackfruit. Fruit you can fry. And after frying, you will get the same color, same taste, but a harder surface. Extra moisture it will remove. Using vacuum technology. And you know this Nendrabale kai. When you fry actually, in jackfruit also when you fry, we make lot of chips in South Canara. When you make chips out of this jackfruit, you can see the color will be little brownish. If I use actually vacuum frying, it will be the same yellowish. It cannot change the color. Nendra Balaka, that you can get the yellow color. What you are getting from the market is colored. It is not the color of the chips, what you get in Nendra Balaka. It is not the same. It is yellowish actually because of the color and salt what they are putting, you will get that color. But in this machine, even if you don't put anything, you can get the same color. You can actually okra products I will show you. This is a machine actually. We are installing in September. I have taken the trial last week, sorry. These are the items you can make. This one is jackfruit, banana. No, this is brinjal, non-vegetarian item. Jackfruit itself. As fruit itself you can fry. Banana, this is okra or lady's finger or bendekai. Bendekai, I think you can see after frying it will become actually soggy, plus along with the technique you can see it will become black, brownish or black. It will be green only after frying. These are other items. Advantage is actually 20 to 25% less oil. See, in this actually the biggest advantage is, even if suppose if we are frying any regular items, even if I make kod vada also, kod vada regularly we get about 42 to 43% oil consumption. Then we use actually the traditional method of centrifugal to remove the extra oil to make it to almost about 25 to 26. Here automatically when you vacuum it, extra moisture is gone from that. Automatically you will get about 20 to 22 without doing anything. But this is a batch process. but retains 95% of the vitamin. Otherwise, actually, in high temperature, the vitamin loss actually is 50%. Here it is just 5%. It is healthier junk food. What we are eating, though it is not good for health, in that actually this is much better than what we eat. This is the Indian core vada. I am telling actually, this actually you can see, this is a process actually we have developed with an Italian partner for making core vada. I will show you the different stages. Initially, you can make any core vada. You can make rice, rava, then onion, all these things we can do. Here actually, I met one guy in one of the exhibitions in Taiwan last year. This was a product for different, mainly it is an extrusion product. He was actually making one new product, which is not similar to core vada. I told him, can you make this? It is made from wheat. That is maida, white flour. He said initially it is not possible. Then I said I will take the trial. Even if the machine goes what I will pay. The machine cost is about 38 lakhs. He said yes. So I went to Italy and shown the product first. Then finished. In the beginning actually I showed how we make manually.
Okay. Good job.
Pause. This is manually we make it. Second stage, I had gone for semi-automatic. It's done by ourselves. It's a Japanese machine, Rivoli machine. It makes an extrusion. It comes with like a rod and cuts it and falls on the tray. Then we make by hand. There initially, to make 35 kgs, we per 8 hour shift, we used about 13 ladies. So with this, we had gone up to 150 kgs by using this method. This is a semi-automatic one. This is a fully automatic one. Recently commissioned, about 2 or 3 months back we have commissioned this. You can see materials. This is actually a completely protected chamber. The product is coming openly. 150 kgs per hour is the capacity. Falls directly to the fryers. The entire picture we have done in today morning, all these presentations. The temperature, 166 is the temperature. That is the speed, belt speed. The new factory we are providing fluid as bed for cooling. Sorry, Tarla, one Next is Nipotto. Nipotto also we made automatic, fully automatic plant. Sorry, it is taken by mobile phone today morning. Video. Here actually when the ball comes actually, it is pressed in a hot press and it will go to the oven and heat and come back. And the entire process will take about 35 minutes. Last one is the freezing technology. You have time now? Another 15 minutes. Cold chain management is actually the difficult process in India at present, but slowly it is coming back. Types of freezing technology, freezing technology, advantage in spiral freezer. Freezing of food preserves. Last, I think, this thing I told about keeping the products in fridge is almost similar to that. Usually what we do is, in the house, we think that actually in the freezer we are safe, 100% safe. Whatever food we make in the morning, by about 10 o'clock it is done, 12 o'clock or 1 o'clock we eat, and we keep it in the night. Night actually after dinner, whatever is left over, we will put in the freezer. We think that 100% it is safe. Sorry, it is not safe. It is actually the microorganisms, we have seen practically every hour it almost doubles. Say for example, actually when we make food at 90 degrees temperature, it is approximately you can say about 0. When it immediately made. Within 1 hour it will become 10. Within 2 hours it becomes 20. Within 8 hours it becomes approximately about 1 crore. After 8 hours it is 1 crore, which might be good bacteria, bad bacteria, both are there. But what will happen is, basically the biggest problem is, we think it is safe. After 8 hours or 9 hours, when we are keeping it fridge, it is safe, but it is not safe. When you keep it at that state, nothing will grow in the fridge if the temperature is more than -10. That means, if it is -8, -7, it is not useful. It has to be -20 according to me. I had seen -18 also we had problem. You have to keep it -20. I will give the guarantee, any of the freezers, including the modern freezers, what we have in the house, doesn't give -20 at all. It will be -6 or -7, not beyond that. Because the number of times actually when we open the freezer or open the fridge and close it is approximately, we have calculated, in any house minimum is about 100 times. Then once you open and put it back, the temperature increase is from, it is supposed to be +4. Always it will be +20 in the bottom chamber. In the freezer, when you open it, if it is -10, it will become -6 once you open it. Within actually, practically it is in seconds, it will become -4. And the product is safe if it is more than -10, even including ice cream. Unfortunate thing is actually nobody knows these things. They think that whatever they put in the freezer is safe. It is not safe. It will not, it may not grow, but the time of putting it, suppose if you put after 8 hours or 10 hours, it is already with 1 crore microorganisms. When you take it out next day, it grows 1 crore into 2 crore, 3, 4 crores like that. Every 1 hour. So it is not safe. 100% it is not safe. If it is safe, if it is kept at -25 continuously, it is there for 3 years. 3 years is the shelf life. The first came actually in the world is the blast freezer. Blast freezer actually, I think earlier actually we used to have everything freeze in blast freezer. But blast freezer, the freezing is, the biggest problem in blast freezing is the temperatures actually we cannot maintain beyond a -18 at the center of the product. It is only good for liquid products where the ice cream is used, or if you put liquid, making ice, this is the best product. Earlier heat was not, technology was not that everybody is using this. Then came the tunnel or plate freezing. That is actually it moves to the product, this is the tunnel, when actually at the end of the tunnel, but the material used is very, very harmful now. I think it is banned now in India. But in 60s to I think 94 actually they are using this tunnel freezing for fish and other things. Next case actually the IPF. This is even today, this is the best method for freezing like peas, small materials, vegetables, all these things actually they use the fluidized bed. Actually from all the directions the freezing air is blown. Now the latest technology is spiral freezer. This is actually the spiral freezer. These are the spirals which actually suppose if we put the product here, entry will be here. By the time it comes out, actually we have to arrange this in such a way, suppose you are putting a solid item, like say an Uddinoda. Uddinoda, I think in one of this thing, I think approximately you can say 175 kgs of Uddinoda we can put. That's about 6,000 Uddinodas. And the time taken for converting that from plus 35 to minus 25 outside, inside, and minus 40 outside, it takes about 30 minutes. So it is a continuous process. It rotates like this. And by the time of when it comes out, the temperature, individual item freezing. See, in blast freezing, what we do, I cannot put vada and keep in the tub and keep it in the deep blast freezing chamber. It sticks to each other. But even then, actually, we pack and freeze it. Here, actually, first we freeze the packets, wherein actually the temperature inside, we call it as core temperature. When the core temperature reaches minus 25, it comes out. Then we pack. Then we put it in the cold storage at minus 25. It will keep remaining time. When it is in the cold storage, it will be minus 25 only. The product is safe for almost about 3 years. The best advantage actually in this spiral freezer is, in the blast freezing actually when you keep in, say for example from 75 degrees we have to reduce it to 30 degrees after frying vada. You take almost about, using a fluid as bed also, we take about 15 to 20 minutes. After that what will happen? In the blast freezer, when you pack vada in a pouch, you have to pack in a pouch. It sweats, product sweats. And the time taken actually inside is approximately in blast freezer about 10 hours. It takes 10 hours to come to the center portion, core portion to come to minus 25. By that time actually the water outside, what is there actually after condensation will fall on that. In the house also I think you might have seen, second time you fry vada, a white crust will be formed on the top. I think you might have experienced. Suppose you fry vada, second time when you fry, after 6 hours or 5 hours when you fry again, you can find a white layer. In any of the hotel if you see that, that means it is the old vada. That is because of the extra moisture which is there on this thing. Here actually what will happen in the blast freezer, the extra portion of moisture becomes actually a snow or actually I can call it as ice at minus 40, because outside it is minus 40. So with minus 40 it will become actually very hard, and when you reforce it, actually the basic problem is actually when it becomes watery, then again the white layer will form and it will not be crisp. This we have tried. It is better than what we make fresh. One of the example actually I think freezing actually why we do is, everybody knows vada. ಹೆಂಗಸರಿಗೆಲ್ಲ ಗೊತ್ತಿರಬೇಕು ವಡ ಅಂತ ಹೇಳಿದ್ರೆ ಮನೆಯಲ್ಲಿ ಮಾಡ್ತಾರೆಲ್ಲ ಗೊತ್ತಿಲ್ಲ. But if you make in the house, even if you make from half kg or quarter kg urundal, in the house actually it should be usually 20 to 25 grams, not beyond that, because the bandli is very small. You cannot have bigger vadas. In that actually what will happen, when you fry, the time taken for this half kg is approximately the number of vadas with 25 grams. In 1 kg you will get about 110 vadas of Maiya's vadas. Is approximately you can say about 45 to 48 grams. When you make 25 it is 220. Half kg is 110. When you make 110 vadas, you take approximately about half an hour. And usually in whether it is in house or in this in restaurants, the biggest problem is time taken for grinding actually. Say for example, my restaurant opens at 7 o'clock. Vada batter will be ready by 6:45 or 6:50. And we grind every 15 minutes about 1 kg. When you make 1 kg, to put that 1 kg, we require approximately about half an hour. And after 15 minutes, it will ferment. Fermentation takes place. Because of that, actually, you can see little oily vadas. Oil consumption is little more. It becomes watery. And if you fry also, unfortunate thing is those who come in the first 7 o'clock batch, they will get very good vadas, hot vadas. 7:15, you will get medium type vadas. 7:30, it is a old vada. 6, 7 o'clock we have fried it. This is there for all hotels, not for me. Because the time taken, if you don't do it continuously, the batter will be spoiled. And if you fry it, actually customers doesn't come, it will become old. The best actually is the frozen technology. When you make actually in the machine, we had made the machine makes about 3,600 vadas per hour. And every 15 minutes we can change the batter, the continuous arrangement we have done. And when we freeze it, whenever the customer wants, we can just fry and give. This technology, spiral, we used actually earlier blast freezing, but blast freezing we faced some problem. This we have tried, 100% accurate. I think it will be installed in August end. You can see Maiya's vadas, it will be the same vadas throughout the day. You achieve freezing up to the core. This is the main important thing. The center core actually, you should attain within 1 hour. In HACCP actually, hazards analysis of control, critical control point. Control point is after making the product within 1 hour, you have to freeze it. That's the technology. And this is very easy because actually it is a continuous process. Blast freezing is not continuous. And it is a wide conveyor, you can put at a time 3-4 products at a time. And what you think is you have to bifurcate afterwards. But here actually the biggest advantage is we can make idli, vada, dosa, anything. Sambar and other things you have to pack and keep it. And no belt lubrication. The belt actually moves on its own because actually the biggest problem in at minus 40 is stainless steel material. The special stainless steel, it should not corrode, it should not actually contract actually at minus 40. It's a special what they have made. It's an Italian machine. And you can see actually the highest capacity I had seen is about 1600 kgs per hour. But these people are using because of non-vegetarian. And very, very high mechanical reliability. I think they say that they have seen 10 years now. This is actually the 10th year. Nothing will happen to the conveyor. They have given the guarantee, and even for us also they have given the guarantee for 10 years. Bi-direction, usually what will happen in blast freezer, only one direction. Blast freezer actually machine will keep, it will blow the air and it will only one side. Suppose if we keep the product on the other side, it won't come. Only thing actually when it is saturated then only it will have. But here actually it is actually coming from both sides. So it is 100% safe. Thermal exchange is very good. These are actually not our product. These are their Italian products. What you see in actually, whether it is McDonald's or Domino's, any pizzas or Pizza Hut, the dough actually what they are making is 100% frozen. Only other things they make it here. Earlier also they are also making those things also. But I think a lot of galata happened in India. They are giving actually the dough which is manufactured. For example, they manufacture, Domino's manufacture in Bangalore, Madras, Delhi and Bombay. These are the places they manufacture the dough and give it to everybody. It comes in a minus 25 chamber and they keep for almost about 1 year. Nothing will happen. What we are eating is safe. See the temperature, I think inside core we have tested. This is actually for the packing, regular packing. Everybody thinks that if you put nitrogen it is safe. It is not only safe, but we have other problems also. Safe means actually safe for product. But for us actually, if the nitrogen is not pure, because we are getting nitrogen from outside, we get actually I think almost about 6 to 8% impurity, which gives the product the biggest problem. So now actually most of the manufacturers we start manufacturing ourselves the nitrogen. Otherwise nitrogen filling is good, but if the product is not good, nitrogen is not good, we will have a problem. Next actually the carbon dioxide. Nitrogen usually used for snacks and other things. Carbon dioxide for liquid and other things. And plain air, we can pack it. For example, rubber idli, it's a plain air. We don't add anything. But it's a packing material which gives shelf life. Have the advantages. Dry products actually fried snacks, powdered milk, coffee, crisps, peanuts, etc. And fresh products, meat, poultry, fruits, vegetables, pastry, dairy products. In any packet actually, when you pack actually the material, the product actually, the life of the product or the shelf life of the product or characters of the product remains stable if all these are correct. The environment in the sense actually, suppose if you may see most of the products which is appearing in any of the shelf, suppose if it is sunlight is coming, it will affect the product inside, both the color, flavor and the shelf life also. And the gas. Peculiar actually we have seen in one of the example is we use actually carbon dioxide in, sodium bicarbonate in most of the items like rava idli, gulab jamun, and we use the soda, this acid also. In gulab jamun we use malic acid. The theory is actually malic acid and alkaline, that is sodium bicarbonate. When it is in liquid form, the reaction starts. Then only you will get the fluffy, the carbon dioxide escapes, you will get the fluffy one. But we have faced a typical problem when the temperature goes beyond 45. This problem came in Middle East. Our packet started bulging. When you open it, everything is inside is perfect. But the packet was bulging. That is actually because of the gas generation, because of the heat. So these are actually, when we change the film, we change it to aluminum, we sort out the problem. These are actually different methods, or I think not required for this. There is temperature, light, hygiene and humidity. Shelf life you can determine. Nitrogen we are using for, what as I told you, for basic materials like the spices, plus you can use it for snacks, fried snacks. This I think you might have not seen, carbon dioxide, usage of carbon dioxide. We use it for a different purpose. Suppose some material, say for example, actually we make, using nanotechnology, we made a product called the buttermilk powder. Not just a buttermilk powder. Because buttermilk you cannot make a powder by spray drying it. Because it, when it is heated up to 180 degrees, it breaks. Buttermilk, you cannot heat it at all. Using nanotechnology, I had made a buttermilk powder, but the problem is actually it contains acid. Because it is a lactic acid content is approximately about, you can say, percentage is about 4.5. With 4.5, it reacts with the atmosphere. If it is a packed in ordinary pack of, whether it is polyester poly with the inside metal coating, it reacts with this thing. We pack actually with carbon dioxide inside, then the product was safe. And nothing was happening because of actually contraction. There are actually the gases involved. Properties required for this is actually highly technical. I think it is not required here. It is one of the technology we use for packing. Actually using the film, we make the mold first. Yes, in the machine. Then we fill the material and we closes it. Problem is. This is actually what you see in Maiya's portable and everything in this form. Actually the film goes and deposit and it is easy film. Easy portable film. This is our new factory. Is almost ready. You can see all the technologies what I have told. Along with that another 15 technologies, new technologies is ready in this factory. By September I think it will be ready. So we will show you most of the people actually I think you can see the factory and come back. And it's in Kanakpur Road. Kanakpur Road 26 Kaggalhalli. After Kagalipura, then Somanhalli, then last is Kaggalhalli. This is built in almost 22 acres. And it's a 1.5 lakhs square foot building. The first building has come now. And most of the machines, what I told, I think almost about more than this, a lot of other automatic machines we have installed. Entire factory is the most state of the art, which is supposed to be India's #1 factory, making traditional items. Because nobody has done. See, a lot of people have done the continuous plants like the, what do you call as vermicelli plants or the other plants where making chocolate, biscuit. These are continuous plants, which are traditionally you can make the machines. But here, most of the machines are actually pertaining to only Indian snacks or Indian spices or Indian ready mixes. We made it continuous. I think once we make it, I think everybody should see the factory and eat the product. Thank you.